everyone, and welcome back to the Leetcode grind. Today we have 2381 shifting letters 2. Now in this problem, this was a bit tricky to understand, but we got it. In this problem, we are given two inputs. We're given some string S, which will be all lowercase English letters, so A through Z, all lowercase. And we're also given an array where each value, each entry in the array itself contains 3 values, which represents the start index within the string, the ending index within the string, and we are to consider them inclusive. And between the start and end index, so in this case 0 to 1 inclusive, we are to make a certain move. Now if this move is 0, then that means we should go backwards, and we'll get into what that means. If it is 1, we want to move forwards. Now, given that we have just A through Z, when we go forwards from A, it's really just getting to the next character. So forwards from A would be B, forwards from C would be D. Backwards from C is B, backwards from A is Z. So Z, so it's a cycle. We can wrap around so that Z, there's nothing greater in terms of a lowercase English letter than Z. So then we just wrap it all the way to the beginning to A, vice versa. And to solve this problem, now to solve it, brute force is really simple. And I think it's worthwhile just going over that solution. So why don't we do that, okay? So just simply getting the initial test cases to pass is actually quite simple. We're literally going to do what they're asking for in that manner, which is nothing more than, well, so first let's get our chars, which is a list of this, because strings are immutable and we want to change a char at that index. Okay, and then for start and some move in shifts, we'll say for cur in range from start to n+1, because it's supposed to be inclusive. We want to say the move, well, let's say this is the move, let's say it's the value. Now the actual move will be 1 if val is equal to 1, else -1. So it'll be -1 if the move is 0. Okay, and then we can add to our chart. Now to make the math simple, because we're only considering A through Z, so that's 26 characters, or if we 0 index it, A will be 0, Z will be 25. We can get the character movement calculation by doing this. So first of all, whatever the current character is, which is chars at cur, now that's going to be some character. And what we want to do is subtract ord of A. So we want to get the ord. So ord is the ASCII value. Now ord of A is 97. So if chars of cur, if the current char, now we're, this is a start and end range, and we're now iterating within this start and end range inclusive. If that value is an A minus A, it's 97 minus 97, this will be 0. Now if this happened to be Z, z minus whatever z is, I think it's 122. 122 minus 97 will be 25. So we'll have some value, and then all we have to do after we do this, we add the move, which will be either 1 if the value is 1 or -1 if the value is 0, if this is 0. And then in the event that we're going backwards, in the event this is a negative value, like so, we're going to take this whole thing and modulo it by 26, because there are 26 characters in the lowercase English alphabet. And I know this is getting long, but after doing all that, we can then this is getting, what is this? Hold on. So let's actually test this out. Okay, return. Now I just want to do this. We're gonna say print, and let's run that. Okay, let's see, let's give that a go. Right, or this will be ord of A. All right. Okay, so let's see, this is what we're printing. So ord of A minus A plus 1 modulo 26. Then we're expecting B from this, so it's char of this whole thing, but after we add back the A. Alright, char plus this one. Okay, now if we minus this here, we expect Z. There we go. Alright. So why don't we actually have a function here? So let's say shift char, and it's gonna take some inputs, and we want to return this. What this is the ord of the start char, and then we're gonna subtract A just to get the 0 index value, and this will be plus some movement. Right? And then now before we continue, let's do a few prints. So print, once again, shift char. If I pass in A and I want to go -1, then I expect Z. If I do Z and I do +1, then I expect A. And if I just do A and I do +2, then I expect C. Let's just sanity check that. So Z, A, C, Z, A, C. Okay. So in terms of this calculation, we don't have to worry about it. We got it figured out. So let's remove that. And let's continue on. Okay. So to do the brute force, we can shift char, call that function on the current char, and whatever this move is. Okay. And then at this point, we can return join chars. Oh dear, good. Now, the test cases will pass until we hit a really large case. So it's judging, and we will hit a time limit exception. That should be coming up soon for something like this. So where did we go wrong, and what can we improve on? That is part 2. So part 1 is understanding this mechanism, and then part 2 is how we can make this this inner loop more efficient. And to do that, we can understand that the concept of the diff array. And the easiest way to make that make sense is actually to go through an example. Okay, so let's actually run through an example here, and I think it'll make a lot more sense. Right, so here's our input, and we can actually draw it out and say, okay, this is A, B, and C. What we did here was make this calculation per shift entry, right? We did, okay, so let's add our indices, 0, 1, 2. What we did was say 0 to 1, because it's 0, we decrement it, minus 1, minus 1, okay? And then 1 to 2, we increment by 1, so index 1 to 2 inclusive, we do plus 1 and plus 1. And then 0 to 2, which is all three, 0 to 2 inclusive, we do plus 1, and plus 1. Now, do you notice anything? Do you notice that when we make some movement, this movement is the same between the start and end range, right? So from left to right, from start to end, once again left to right, they share the same movement, and this movement is either plus 1 or minus 1. So if now if you look here, this ends up being what, 0, and then this ends up being 2. Well, no, this and this cancels out, so this actually ends up being 1, and this ends up being 2. And if you notice, A, B, C, with nothing applied, A stays the same. B plus 1 becomes a C. So that's A, that's C, and that C plus 2 becomes an E. Now, what if instead of doing this per shift, so we have 1, 2, 3 moves, what if we can do this without the inner loop? And the way to do that is to do ranges. Now, when we get this, instead of, updating minus 1 for all the values, now in this case we only have three values, but let's say it was like A, B, C, D, E, F, G. Instead of doing it for the whole range, we really only care about where does this begin? Where does our movement begin? It actually begins at this index. So because the movement is minus 1, we'll say, yeah, okay, great. Minus 1, great, done. And then where does this end? It ends here. So we want this to apply. In fact, let's remove this guy. Oops. Let's remove this guy. Is there any way to make this bigger? Bear with me. Okay. So let's say instead of doing that, we only want to do it once without the nested loop. So instead, okay, so this movement, it begins at 0. So it begins here. It's a negative movement. And as long as we're tracking the curve value, we know that this, unless we end it at some point, this will be valid until the very end. And it'll only be undone or reversed after the end because this is inclusive. So if it should apply to 0 to 1, it should stop at index 2. So then whatever this is, we can reverse it and say +1. Okay, now here, so we did 1. So we're trying to do O of n. And we can do that if we only visit once per input array shifts. And then for this one, from index 1, we can update here. You know, this can be an array too. We can update here as +1 and we can say after 2. So if this is index 2, then after that we can undo this guy. So in this case, if it's a -1, to undo, to reverse this, it's a +1. But if it's a +1 that we're working with, because this is a, you know, forward movement, to undo this we do -1. Okay, and then the last one, this guy, from 0 to 2. So what's our movement? Our movement is plus. So then we already have a value here. We're going to update this as, you know, with 1. So -1 plus 1, that comes to 0. And then 2. So up until 2, whatever we've done applies, but at 2, which is here, we want to undo the +1. So after, because we wanted to apply to here, we're going to do minus 1. Minus 1, which is -2. I feel like that wasn't very clear. I hope it makes sense. So whatever we did before, where, you know, right now we have one array that tracks. We're gonna track the total amount, so that we can just have one loop, and maybe the code will be easier. Okay. So here, a similar concept, we can reuse this. What do? We're going to keep track of the total moves. And the total moves, we can initialize as 0 times. Let's also get the length of the input string. We're going to say it's going to be whatever that input string is +1. And the reason why it's +1 is, once again, because whatever movement, whether it's, in this case it's a minus, 0 is a minus, or in this case it's a plus, whatever our movement is, backwards or forwards, we want it to apply to the start and end inclusive. So if we say, you know, apply something here, and then we want to apply it to here and here, whatever we're reversing or undoing must be after the ending range. And that's why if we're starting from here and ending here, then we want to reverse or undo our action after the end. And so we add an index 3 just to handle that case. Okay. And then we say, all right, so first start, end, and val and shifts. Forget the nested loop. We're not doing that anymore. We still want to know what the movement is. Okay, whether we're going forwards or backwards. And we say moves at the start index is going to be plus equals move, right? We're gonna accumulate whatever move we want to do at that starting position, and then all we want to do is remember that after the end we want to undo move. So whatever this movement is, whether it's positive or negative, we want to log it to the start, and then after and beyond the end, right? Beyond the end, we want to undo what we do here. So we want to reverse it. Okay, and then so that's one loop, O of n. This is the second O of n, so it reduces down to a singular O of n. We do our second loop will be to actually do the calculation, and to do that we need to track the current move, which will initialize to 0, and then we'll say for move, yeah. So all of this work is to do the move. So cap the moves. Okay, and here we're actually doing do the moves. For move, for I in range n, for I in range n, and I think that should work. Okay, we can say cur plus equal moves of I. So we want to log the whatever nth char and nth move we're working on. Let's add it here. Great. And then chars of I will equal, let's use this here, shift char, where the starting character is what we pass in and the move is the current move. Alright, so moves of I has the individual move, but we're tracking the ongoing movement. And then once we do that, yeah, actually that's it. Yeah, so this already has the moves, whether it's the plus movement, minus movement. By the time we finish this here, this block, in a singular array, we've already consolidated, if this was +1, -1, +1, we've already consolidated this. We've consolidated this into a single array. So we have all the moves, and then now we're doing the moves, and at this point our chars is already calculated, so we can return a joint. Let's give that a go and submit. I know this was not the best explanation. It was hard to understand. Best way I would recommend is to actually go through these examples and run these through step by step. But if I can emphasize once more, the main parts to understand is there's two things. First is this wrapping around and this this business, and the second is the concept of consolidating the moves in one go and using a variable to track the ongoing moves. The main thing is, for the second part, is that we're applying some action, whether that is a movement backwards or a movement forwards. We're applying that action to the beginning. We're remembering it in our moves array, and instead of saying from the moves, from the start, that can be index 1 until the end, let's say that's index 32, instead of updating the values for each of the values between the start and 0 and 32, we're just saying at 0 position we're going to start some movement, we're initializing some action, and at the end, let's say that's 32 or 302, we're going to reverse that action simply by negating it, because each movement is only one forwards or one backwards. And after calculating all the moves and log in at the end, because it'll update, this will all be consolidated. We're just gonna keep a track of the ongoing moves and then update the charts accordingly. And I wish you luck. Once again, this is 2381 Shifting Letters 2. Thanks so much, and happy coding, and hope to see you next time.